Okay, so the only thing I want to add is a fill in the blank sentence that you can use to interpret mean and standard deviation. So I used to make them write two separate sentences and they get super repetitive, so I'm kind of writing it as a continuation of one. So over here, I'm going to write which part goes with which. So this isn't if we do it once, it's if we do it a whole bunch of times. So many, what does it mean if I do something in a different color and something like that? That's where you fill in for each problem. This applies to ones that were randomly selected, which is kind of implied. We haven't really explicitly said that. We expect the average, whatever our variable in context is, to be about, not exactly, and this is where you put whatever the mean number is, and then don't forget your units. So the one about, what was it, errors on the undergraduate essays? Is that what it was? Number of errors. So it'll be if many undergraduate essays were randomly selected, we expect the average number of errors to be about, what was the number? Is that one? 3.031? 2.1 errors. That's just errors, right? Because our errors per essay would probably be better. Non-word errors. I knew it was something else. And then so this part interprets the mean. And instead of rewriting that, I'm going straight into what is the definition of standard deviation? Average distance from the mean. So we're basically just going to write that out. And we expect the, I guess, number of is could kind of change. So, and we expect that to vary from the mean. By what you said is an average of. And then again, we're dealing with about whatever our new number is.
Or what our standard deviation is.
Yeah. And then don't forget your units again. We didn't calculate standard deviation for the non-word errors. Is that right? So let's pretend it was like 1.2. Then you would say what? Okay, so what was that? 1.13. Okay. And we expect the number of non-word errors to vary from the mean of 2.1 errors, non-word errors, by an average of about 1.1385 non-word errors.
How do we get the 1.13?
That was the answer we got, but the one I said don't interpret it. Number 15. And some people would have been okay maybe writing out. I think this is one of those where, like, if I asked you individually, what does this mean, what does this mean, you'd be fine. But if I said write it down on paper as an interpret, some of you, the majority of you would be like, I don't know where to start. So it's nice to just have a fill in the blank to interpret. So if I'm giving you a fill in the blank to interpret, probably expect to have to use that on the test.
Are we going back to 13?
I think we can be fine without doing it. Does anybody need me to go back over 13? Like, I'd rather just not go over it if it's going to confuse somebody. Because I don't have it pulled up, then I'd have to take a picture and all that stuff. The only thing I didn't go over is B and C, right? And C is the same thing as just putting in words. I'm not worried about that. All right. It's actually just talking about they could just deal with the average of the first, or average of a number to see how far it was off, to be able, kind of like with the Medicare fraud thing. They don't have to, like, literally look at every number. They can look at the mean and see the mean's off and know it's off. All right. So today. This should be relatively easy because it builds off of something that we've already done. So I'm going to talk through the part that we've already done first. So this part's not on there. This is just a, hey, remember this. So let's say that this club is dealing with selling candy. And we're going to break down, if we have all their number of boxes sold, we can break it down into different ways. So each player was required to sell at least 2 boxes. Any additional boxes sold would go towards funding a field trip. So how many boxes did each member sell that went toward a field trip? So I took all of my original values, and I'm going to do what with them? This is not on your worksheet. I'm going to just subtract 2 from each one of those. That's what the context is saying, right? So this is telling me all values, subtract 2. So I calculated all this stuff we don't need to do. What would happen to my new mean? What would my new mean be versus my old mean? What else would be 2 less than it was before?
Q1. Q3.
With the rest of them? What happens to your standard deviation?
Stays the same.
What happens to your interquartile range?
Same.
So these are measures of what?
Spread.
So spread stayed the same. What happens to my shape? So when we add or subtract, your spread stays the same, your center changes with it. These are individual values, so it's just asking about individual values there. All right, so in this scenario, same thing, except this time it says each box contained 15 candy bars. So now we want to do it in terms of how many candy bars did each club member sell. So we're going to take our original values and now do what with them? So our original values were number of boxes sold. So now what am I going to do with the number of boxes sold to get this answer?
Subtract 30.
Multiply by
15.
15. Alright, what's going to happen to my mean? Multiply by 15. Let's skip around. What's going to happen to my median? What's going to happen to Q1 and Q3? So, like I always say, center happens exactly what you would think would happen to it. If it's your mean, if they multiply all the data, your mean is going to get multiplied. If they add all the data, your mean is going to get added too. What happens with spread in this scenario? It also gets multiplied as well. So it didn't get affected by adding, subtracting, but it does get affected by multiplying. What happens to our shape? Because if it looked like this and I stretch it out, it still looks the same, right? So measures of center get changed exactly how you'd expect them to. Measures of spread only get changed by what? Multiplying or dividing. Spread always, shape always stays the same. So, different scenario here. In art class, the students are making quilt squares. All students start with 3-inch by 3-inch squares, their idea. This one person decides they want a bigger square because it's going to make his really detailed. So, instead of a 3-inch square, he decides to use a 9-inch square. So, mathematically, what am I doing there? Multiplying by 3. Now, how many square inches of material would he have needed to make a 3-inch square? Right. Now that his is 9 inches, how many square inches of material will he need? So, our original was a 3-inch square. How much material did we need? 9 inches. The new one was 9 inches, which means how much material would we need? So this one was multiplied. This one got how much? Oh, I'm going the wrong direction here. This one got multiplied by what? What did this one get multiplied by? Which is, how do I get 9? Multiplied by 3 what? Do you understand this idea? Everybody's with me with that, right? How do I get 9 inches squared? I just take this and square it, right? So whatever this is that squared. Well, what's our symbol for standard deviation? What's our symbol for variance? So this relationship works with how variance would work in this situation. So if I had an original standard deviation of 2, and I added 7 to every value, how is my variance going to change? Stays the same. Because does standard deviation get changed by adding and subtracting? Does variance going to get changed by adding or subtracting? If I take this and multiply by 7, what happens to my variance? It gets multiplied by 49. Does that make sense? And I could go through and take this, multiply it by 7, and see individually here. That means it was 4. Take this, multiply it by 7, so now it's 14. What is 14 squared? That times that times 49 would give me that. And I could go through the math the long way if I needed to. But I just need you to see this idea. If you can understand this idea, you can understand the relationship between standard deviation and variance. Alright, so look at this first example. So now we're on your notes. A large auto ship dealer keeps track of sales made during each hour of the day. X is the number of cars sold during the first hour of business on a randomly selected Friday. Based on previous records, the distribution of X is as follows. Right now, find the standard mean and standard deviation. Ready, go. And show work. And it told you this is X, so you're doing mu of X and sigma of X. Do what? So what do I get as my answer for me? And my units are cars sold. So I could go through variance, writing out my equation, but the standard deviation is the what of variance. So if you don't want to write them both, because we're not going through them, just write that this is the square root of, and then do your work. So this one will be written out as, what's my first number? What do I do with that?
Minus 1.1 times 0.3 squared.
And then do that for each one. So then 1 minus 1.1 squared times 0.4. 2 minus 1.1 squared times 0.2. 3 minus 1.1 squared times 0.1. And so you can write that, since if you're using your calculator, you don't have to go through variance, I'm okay with you doing it that way. And we end up getting to 4 decimals what?
0.9 for 3/4.
And what are my units? What would my units be for variance? It doesn't have to make sense. What would my units be? Cars sold squared, so would that make sense? So sometimes it gets confusing writing variance when you're trying to do your units. Alright, so suppose that the dealership's manager receives a $500 bonus from the company for each car sold. I always have people who get mixed up between, so let's look at 2 and 3 together so we can talk about the difference at the same time. So suppose the dealership manager receives a $500 bonus for the company for each car sold. Number 3 says to encourage companies to buy cars on Friday mornings, the manager spends $75 to provide coffee and donuts. Which one matters how many cars were sold?
Two.
Number 2. because if I sell 4, I get $2,000 bonus. If I sell 1, that's $500 bonus. Number 3 doesn't matter at all with how many cars you sell. It is just a one-time deal. So which one is multiplying and which one is multiplying, dividing, which one's adding, subtracting? 2 is multiplying because we're multiplying it by how many cars are sold, so it matters how many cars are sold. So 2, we're multiplying. It's already given us our new letter and defined it for us. If it hadn't done that, we would need to do that. So now I can go straight into how do I find my mu of y. Now you are going to have to show work a little bit here, but not like terribly. You have to show step by step. So I am multiplying what by 500? Not number. Symbol.
Wait, is it what the bonus you receive? So you divide by 500 to get the first sold.
You get a bonus for each one. So it's like, it's how much did you get? What? So what do I do with 500? Multiply by what mean? Which is the mu of x. So that's what I mean by show your work. And then so what is mu of x? So this now gives me, and what are my units? Dollars.
Where'd you get the one for one?
The one we just wrote before that about. You're taking
Oh, you're
the answer there. So our new mean there, if in many first hours of business on Fridays, randomly first hour of business on randomly selected Fridays, we would expect to get about the bonus received from sales would be about $550. So what do I do for sigma of y? How does standard deviation get changed when you standard deviation get changed when you multiply? Yes. So what do I write based off of doing that? What do I write now? 500 what? Before that, which is 500 times 3, 4. Yeah. Which gives you what? So that means we expect the amount of bonus received in the first hour of business on Friday to vary from the mean of $550 by an average of about $471.70. Does that seem very good? Seems very inconsistent. So maybe good, maybe bad, but definitely inconsistent. Alright, so now here we're building off of it again. So to encourage customers to come on Friday mornings, the manager spends $75 to provide coffee and donuts. So now they're taking their bonus earned from number 2, and this one literally says minus. It shouldn't have needed to tell you minus 75 there to realize you're subtracting $75. You got a bonus, but you were paying for the coffee. So it gave me my letter 2. So now I'm saying mu of t
It's mu of y minus 2
minus what?
75.
What was my mu of y? So now it is What about my sigma of t? Because why? Spread does not change when you add or subtract. So if I take the whole distribution, slide it over, I didn't change how much it was stretched out. So it stays at 471.70. So maybe this manager should learn math before he decides to do what he's doing. A lot of the examples we use are things that people would do without understanding it because they don't understand math. I want you to do the next one really quick. So this one should not require much work. Let's come up with so you've got to have some kind of lettering here. I just did one super basic. This will give you absolutely no context. Because we had mu of x, sigma of x, but now we don't know what letter to do mu of x, mu of what, and sigma of what. So what do I write beside mu of n? Okay, I am multiplying and I'm adding. What happens to my mean? Does this happen? Does this happen to my mean? Does this happen to my mean? Okay, so let's write that out. So my mean was mu of x. What do I do with mu of x? And then I'm just plugging in my numbers. So my mu of x was which gives me, and it doesn't even say units. Might make me feel better to write units there, just so that you know that you're supposed to have units. So for sigma of n, what would I write?
Mu of x plus 3.
So you don't include the plus 3 there. And what was our original sigma of x? So that's just like a really quick reminder what you do and what you don't do. I really don't want to do all this problem because I hope to be farther along in this. Let's go through it really quick. This problem is talking about the number of problems correct on a 10-question quiz. And then we can convert that to make it a percent or a score by multiplying it by 10. So mu of g How do I find mu of g? These are x already. So x is the number correct. Yeah, x is the number of questions correct. So how do I find mu of g in terms of a grade now?
Multiply by 10.
So mu of x times 10. My mu of x was 7.6. So now it's 76. Which again, I don't like to have units. We'll call it 4. I'm just, now when I require you to write score or something on the test, no, because the unit's kind of not there, but I want you to get in the habit of doing that. So what did I do for B? Sigma of G equals what? Times 10. What's my sigma of x? Points might make more sense than score. I don't really care how you write this though. How would the variance of x compare to the variance of g?
The square root.
So think about when we talked with the quilt squares things here. So my quilt square going from a 3-inch to a 9-inch got 3 times bigger. But how much bigger did the actual square area of the square get? Why? Why did it get 9 times bigger? Because what squared? It got 3 times bigger, right? So the area got 9 times bigger because 3 squared is 9. So here, my data, x, is how much bigger, or g is how much bigger than x? 10 times bigger than x. So my variance is going to be how much bigger than it was? 100.
I don't quite understand why. I didn't understand.
I'm just taking that squared
The why are you squaring?
because variance is squared. And some people are going to be like, that makes sense, just like the quilt square. And if it doesn't, that is absolutely fine. Think about it in pieces. So my standard deviation was 1.3, 1.32. My standard deviation, you don't have to write this if you don't want to, was 1.32. When I multiplied it by 10, it became 13.2, right? So my original variance, what is 1.32 squared? So I just type in 1.32 squared. What do you get?
1.742.
What is 13.2 squared? So how much bigger is that than that? So if the quilt thing doesn't make sense to you, just go through this process and do the exact same thing. Just go through it in pieces. So mu of g, I'm just writing this really quick, equals mu of x times 10. Our median. There's no symbol for median. Some books try to use something, but there's no like overall. The median of x was 8.5. 8.5 times 10 gives us 85 score, 85 points, whichever way you're writing it before.
So shouldn't that be median of G? Not mean.
Oh yeah, median. Some books try to use a capital M or try to use MED, but it's inconsistent, and I don't like the fact that it's inconsistent. What happens to our interquartile range? Gets multiplied. And what was our interquartile range? Didn't give it to us. We can look at that real quick.
1.
What's going to happen to the shape? Stays the same. What was it originally? What was it originally? What? I think I'm hearing both. Which skewed? Left? Why? Mean is lower than the median, and I can look at like my 5 number summary here with those 5 things. Half of it is between 8.5 and 10, and the other half between 4 and 8.5. I could bring in those if I wanted to. 75% is 8 or higher. It's 25% is between 4 and 8. A lot of different ways you could look at that. So the stays left skewed. I think I'm going to leave the last part as part of your homework for this worksheet.